Hello, welcome to Excellent Link Academy. Let's look at yet the shortcut to log function of differentiation. Last class, we did an introduction to log function of differentiation. For this class, we're diving into the shortcut of log function. How do you apply the shortcut and why is the shortcut important? Basically, the shortcut is important when you are having several functions, right? If, for instance, they combine both exponential and log for it together. So for you to solve that problem easily and quickly, you have to apply the shortcut. Basically, the shortcut has just two steps. The step one is to differentiate the term in brackets as your answer for numerator. The second step is to repeat the question as your answer for denominator. What am I saying in essence? Let me repeat myself again. I said the first task there, differentiate this term in brackets as your answer for numerator. Repeat that question as your answer for denominator. Guys, get that thing done. Alright, example. Let's say I have y equal to log, let's say 4x squared minus 5. Let me just use another figure. Let's say 6 here. For instance, let's solve this. To apply my normal procedure that we know, we said first task, call this u. So first task, you call the term in bracket u. Let's not apply shortcut yet. Let's hold on. We said your normal step is what? 6x squared minus 5. The u over the x here is 12x. We said that y is equal to log u, right? So from here, the y over the u is equal to 1 over u. Now next up, from here, using what? Chain rule. Using chain rule, what do we know? The y over the x is equal to the y over the u times the u over the x. I expect that we should know how I got to this because we have done the introduction. So try checking our previous videos so you understand how we got to this. From here now, the y over the x is now equal to the y, the u is 1 over u, 1 over u times dx is 12x. So I have 12x here. 1 times 12x is of course 12x over u as the y over the u. But I can't, sorry, the y over the x. But I can't express x in terms of u. So now I see u, I'll put what? 6x squared minus 5. So I'm saying that the y over the x is equal to 12x over what is u? U is 6x squared. 6x squared minus 5. So this is my final answer after differentiating this particular question. So I have 12x over 6x squared minus 5. This is your normal procedure. Let's now apply shortcut. For the shortcut, we have that y is equal to log, that's 6x squared minus 5. So the shortcut is that we said differentiate the term in bracket as your answer for denominator. The second step is to repeat the question, or you call it the function as the case may be, as your answer for denominator that we said. So from here, straightforward, y with x, I'll have the y over the x is equal to differentiate the term in brackets. I'll have just 12x as your answer for numerator. Then repeat the question, the term in brackets, that's 6x squared minus 5. So this is how you solve the shortcut. So observe this and this, they are the same. Observe. So this is a shortcut. Shortcut, differentiate term in brackets as your answer for numerator. Repeat this question as your answer for denominator. So this is solve log shortcut. Basically, example 2. Let's say I have that y is equal to log log let me use a special function log exponential 13x minus 4x squared. For instance, let's say I have this. Let's apply shortcut to this. So how do you solve this using shortcut? You say your first rule is to call the term in bracket u, and basically my normal term that should be in the bracket is this, right? This one is in the brackets. So first task is to I'll have that the y over the x is equal to differentiate the term in bracket as numerator. If I'm differentiate exponential 13x minus 4x squared, I'll have I'll have 13 minus 8x exponential 13x minus 4x squared. Because of the aeroplane, so the noise will not disturb or contradict each other. So we said first task is to differentiate the term in brackets as numerator. Differentiating exponential 13x minus 4x squared, I'll have this as my answer. How? Go and check our previous classes on the shortcut to exponential function. For this one, 13x is just 13 minus differentiate 4x squared, I'll have 8x. Then repeat the question. This one I have it. That's a shortcut. So all over. What's the next task there? Repeat the term in bracket. That's exponential 13x minus 4x squared, as we said initially. Right? Repeat the question in bracket as a denominator. So what do you observe? We expect that this one here should cancel this. So I have what left? The y over the x will be equal to 13 minus 8x as my final answer after solving the shortcut of logarithmic function of differentiation. This is how you work with basically the shortcut of log function. Next class, we'll look at the trig function of differentiation. We're having sine, cos, tan, cosine, cotangent, cosec, and etc. We'll look at how to differentiate those concepts. But for then, we'll look at yet several past questions on differentiation, whereby we'll be combining several concepts like chain rule, product rule, quotient rule, log, density function, exponential function, all together in the question, and you'll see how to evaluate those problems in the next class. All right, see you guys in our next class. We'll be looking at several higher examples.